Section 3.9, Linear Approximations and Differentials. We have seen that a curve lies very close to its tangent line near the point of tangency. In fact, by zooming in toward a point on the graph of a differentiable function, we notice that the graph looks more and more like its tangent line, which we saw in Figure 2 in Section 2.6. Now, this observation is the basis for a method of finding approximate values of functions. The idea is that it might be easy to calculate a value f of a of a function, but difficult or even impossible to compute nearby values of f. So we settle for the easily computed values of the linear function L, whose graph is the tangent line of f at a f of a, which you can see here in Figure 1. So here is the line y is equal to L of x. Here is the function y equals f of x. And then there's that point a f of a. So in other words, we use the tangent line at a f of a as an approximation to the curve of y is equal to f of x when x is near a. And so an equation of a tangent line is going to be the following. Well, first, let's talk about what we have here. Well, we have a point which is a f of a. So that means that this represents x1 and this represents y1. And so what we also know is what the slope represents. The slope is the rate of change, which is the derivative at the point A. So what we're going to do is go back to our point slope form, y minus y1, which is equal to the slope times x minus x1. And what we're going to do is we're going to replace y1 to be f of a, which is equal to the slope, which is f prime of a, times x minus x1, which is a. And so therefore, if we solve for y, then we're going to get y, which is equal to f of a plus f prime of a times x minus a. And so therefore that gives us our first definition. F of x is going to equal approximately f of a plus f prime of a times x minus a. And it is called the linear approximation or tangent line approximation of f at a. The linear function whose graph is this tangent line, that is L of x, which is equal to f of a plus f prime of a times x minus a, is called the linearization of f at a. And so the next example that you're going to see is typical of situations in which we use a linear approximation to predict the future behavior of a function given by empirical data.